Good day, good afternoon. Welcome to this webinar. We'll kick off the introduction. So this will give time for the new latecomers to join us. This webinar is part of a larger series of webinars that is cross views on AI and water science. So two sections today. So student session. So these are students of the masters, students in masters, and we're learning how to use AI in the water sciences. And we'll discuss the works we've done dealing using these technologies, and we'll discuss our understandings and questions and their views and perspectives on AI. Second section of the seminar will be called From Theory to Practice. It will take place on Friday from 2 o'clock to 4:30. It will include researchers, engineers who work in water science and who will give concrete examples of their utilization of AI for water science. Today's program, there will be Integrated Watershed Sciences master students who will present two projects they've done this year. The first one used what we call the generative AI, that is AI that can generate images. And the second is a vulgarization article on AI published in the Decode journal. Then the for those who don't know, this master, IWS, is a multidisciplinary international master which comprises students coming from various domains, and they work together in a cross-way, transversal way on all water-related problematics and propose innovative and holistic solutions. So we report to the H2O Lyon school, and this is part of the Water Week. Then we'll hear Paul Audisio, who is a PhD student. He will study how to study the dynamics of river. So he uses a model that improves the quality of satellite images, Landsat, and by combining them with images with higher uh, precision, but he works with the laboratory of physics of the École Normale de Lyon and with the mixed environment city society, and he works within global research projects. Then the third part to the webinar, there will be discussions between IWS students and Pierre Edusio on the way we use AI in a university framework, but also and then we will discuss the way we understand the tools, the perspectives, and the questions that can be raised. And this part will be a debate among students. We'll express our views based on our personal and professional and student experience. If you do have questions at this time, you can address them to individuals or to the discussion. They will be, well, the discussion will last about 30 minutes. Friday's webinar, we will welcome three speakers. First one will be because Nicolas Bagatti from works on the ground humidity. Pierre Lemaire, a research engineer specialized in computer vision and machine learning. He works in the 6-4 sticks for the office. Finally, Emma Szymanski from Luxembourg University. She will discuss water contamination with chemoinformatic, and environmental approaches. These are webinars organized by us, the students, uh, within the framework of our. We worked on the utilization of. We studied. We studied state of the art, but in different aspects on detection and prevention of leakage. We can do. We discussed teledetection, thermal dimensions, and based on this, and with a new teaching unit, which is supervised by Antoine Vernet on the LINA, part of the promotion of our group published a vulgarization article with high school students in Lyon on the utilization of AI for water management. And it was published in Decode, which is a vulgarization journal for scientific article for high school students and secondary school students. I mentioned early on the used works using generative AI have been mentioned by some students, and this comes in addition to all the works to disseminate the knowledge we gained and the work we've done, and which will be presented in addition to other speakers which use AI in their work. As Clément said early on, and before listening to the speakers, let me discuss the content of the article published in Decode, which we published with high school students from Louis Perrin Lyon School. And we will specify what AI do so that we understand the basics. The definition is AI. It's not exhaustive. There are many you can find many on the internet, but the definition I use is that of the European Parliament, which says that AI, all systems that have intelligent behavior by analyzing their environment, by taking actions with some degree of autonomy to achieve specific goals. So from a query, user's query, the system's AI can analyze, reason, and process data at variable to respond to the query. This notion of AI comes at the second half of the 20th century following Turing's work on the measurement when he assessed the intelligence of machines that corresponds to the utilization of the so-called smart machine program, which can fulfill jobs or tasks associated with human intelligence. There are also the machine learning or deep learning, which are subdomain. Machine learning use algorithmic approach to give computers the ability to learn from the data, and they can do tasks without being programmed for it each individually. So they can also do prospective or forecast. The second one, the deep learning, which is a subcategory of machine learning, use network neuronal artificial network to mimic human brain, and they can solve more complex tasks, but which call for higher computing power. Within the framework of our university work, so we make a difference between AI. We divide it in different domains. For generative AI, which can create contents which could be text or image videos based on a description using provided by the user ChatGPT, for example, are the best known in this domain. Then we've got the predictive AI, which combine statistical analysis of events that took place with machine learning to identify patterns and anticipate behaviors and forecast upcoming events. They could be used like in Ghana or near along the Pra River, which make it possible to identify the pollution caused by informal extraction. But we can also combine machine learning with deep learning to anticipate on the water temperature by identifying patterns, and this is done from a large database. Then there is a cognitive AI, which mimic human thought process. It can learn, reason, and understand languages as humans would do. Last category, which is not it's the embedded AI. So it's AI that will be integrated in devices or systems. It could be different size, different power, like smart sensors that will collect on-site data, and that will be this data will be analyzed by machine learning systems, or embedded AI in satellites, like for the European Space Agency, they combine teledetection with AI to, at the time of capturing images, which they will identify which ones are cloud covering uh, images that will prevent saturating images. So this is what we did, and now we'll give the floor now to uh, two speakers. So they will discuss generative AI. And so Margot Predom and Océane Jouet. Hello. My name is Margot Predon, and we will describe the work we've done within the framework of teaching together with Frédéric Cherki on generative AI. These are works carried out with two other individuals who are here today, Arnaud Forêt and Donald Bocco, and where we will describe the works and the results obtained. Thanks to this generative AI system. First, the general context. The initial problematic is that of climate change and adaptive solutions. As I just said, current situation of climate change, which leads to a higher number of what we call hot days, or and an increased risk of flooding, but at the worldwide scale. These, you see two bodies of work. The first one was done on the number of days of hot days. You see the city of Lyon is quite concerned here. You can see here, okay? So this is the city, and other works uh, carried out on flood risks. All those changes, in fact, are causing problems, and especially in high population cities like Lyon, because they create vulnerability. Therefore, we look for solutions, and within the framework of Lyon, it is the heat issue that is at stake, because we got heat islands, and one idea is to expand green and blue infrastructures. So what are the blue and green infrastructures? Well, we want to everything which is vegetation, small gardens, uh, uh, cool zones with fountains that will mix water and vegetation. In order to do this, we used the software Focus. Focus is a program. It's an open source generative artificial intelligence program, which makes it able to generate images, to change images using prompts, text prompt. How do we use it? Well, we CC, we find an image, we take a snapshot, we will import it into the software, we create a mask, and I will show you with screen capture what it looks like, and then we will create a prompt that will enable us to do the modifications. What is a prompt? I'll try to be precise. Well, it's a short instruction text which is guiding the AI system as to what we wish to see as an image. It has to be very precise, the text, because as we've seen by using this software, each word is essential and will lead to different results. In our case, we use mainly what we call the in paint and out paint. that is, will add step by step elements and remove other elements. So it's a step by step approach. And therefore, we will also download the images on the run to avoid too complicated prompts that would change the images obtained. So, for example, those are screenshots. How to use, so you see the main image, which is the Bellecour Square in Lyon. The white space is the mask that has been created using a specific tool. And at the top, next to the generate key, there is a prompt. Though the idea was to do gardens, well, flowers, and a path as well. And you can see the result obtained at the end. Focus always proposes two results, and then you pick up the one you like best and you want to keep. Another point to be taken into account is that it is possible to use that tool by downloading the software, but also directly on the internet through a Google Colab. And this is what most of us have done. I will now explain the methodology we followed this for this project. We relied on the work of Bach and Prodanovic, 2024, where they developed case studies with approach on the undesirable futures and conception to adaptation. And in fact, we were able to work with them by discussing in order to refine our images and to adjust some details. And we used exactly the same tool so that there will be a coherent approach. Of course, there are other tools, AI tools, to generate or modify images, such as DAL-E or Midjourney, but each AI offers different possibilities. We followed the two approaches. First, we focused on undesirable future. The two scenarios selected were drought and floods, with the construction of prompts that Margot just described, based on two opposed aspects. First, with drought, like dry stone, grass, cracked land, and a word like storm, cloud, and for the floods. The objective of this approach was to bring some kind of well, to explain to the general public, sort of images with more immersive scenario, leading to less imagination. Now, for ideation design, the idea was to integrate green and blue infrastructures, as Margot explained, in zones where concrete is highly present with limited shade. So the idea was to improve water and filtration to fight against it, but also to make sure that the space would be multifunctional. And several solutions were considered for this approach, especially gardens with prompts such as design based on French gardens with flowers and grass. Also the solution of grass and trees with prompts such as structured space, integrating rows of trees, or a solution such as water mirrors with prompts such as uh, a water basin reflecting the sun rays. So we had to be the site had to be symbolic and well known, but also they should provide material for our problematics. For undesirable features, we selected two sites, very emblematic: the Rhone at the Hôtel Dieu and the banks, and the Tête d'Or Park, which are essential for the history, the culture there, and also they play a role as shelter when it's very hot. In addition, these sites were selected because they were impacted by the floods of 1840 and 1850, 70, as you can see on the map. So the 1840 and 1856, you can see the locations where the zone were most vulnerable to the large floods. For the ideation creation sites, two sites were selected, two squares, the Place Bellecour and Place des Terreaux, Bellecour and Terreaux squares, which are locations with a lot of traffic, human traffic, circulation, a lot of major events taking place. And we wanted to integrate green-blue infrastructure while preserving the heritage, and to combine all the functions. First, I will describe the results from we obtained, myself and Arnaud on Forêt, on the undesirable futures. The first site selected was the Tête d'Or Park, and you see the two images that we selected, one which would be the lake and green space, and one with just the greenhouses. Now, for the first image with the greenhouses, two results. This is based on scenarios we built we designed to shape the images. You can see a scenario, some dark for the greenhouses. But the first image would be trees which used to be blooming, and which today they provide little shade, and the greenhouse has lost its collection of vegetables simply because droughts and floods have destroyed this biodiversity. So likewise, on the second image, you can see the floods. What should be interesting with this image is that since we got a building, we see the scale and the level of water, which is less obvious with the second image. So the lake, for example, you see on this image, we had the same scenario, wanted to show a disaster of the landscape, a sort of a stressed landscape. First, with a drought, the land is cracked, lake is almost dried, it's just mud. And on the other side, the flood that we imagine because of torrential rain with the soil is no longer able to absorb water and causes more and more floods. For the second site, which is the Hôtel Dieu and the banks of the Rhône River, we've integrated time dimension with a near future and distant future. Short-term drought could remain intermittent, leaving water in the river still. But throughout the years, in the long term, we could end up with drought to be more fierce, severe, and they would entirely dry up the Rhône River. And these infrastructures, as you see now, the banks of the Rhône would be ignored by the population, which they will have no leisure or recreational functions. Last result was these two images on floods. Again, it's a bit more complicated to realize if we can be long-term or short-term, but anyway, it is clear that floods will flood all access roadways, possibly the first floors or basement or the ground floors of buildings, causing huge damage. And of course, this would entirely block the city. I will now give the floor to Margot, who will describe the results for the ideation and design. These are the results we obtained with Donald on this notion of green and blue infrastructures, or blue and green. So like for Océane and Arnaud, two squares with different photos. First, results for the Bellecour square. As Océane said, we wanted to implement green space and water. You see an example with green spaces. On the left-hand side, a garden, as well as trees and grass. For this idea of grass and trees, again, two parameters have to be taken into account. And generally, when you want to do generative AI and try to do ideation and creation, is to take into account the characteristics of the location of the site. For the Bellecour Square, there is a parking lot underneath, and therefore it's very difficult to do trees in the middle, to put trees in the middle. So two ideas were exploited. On the middle image, you see planted trees which are in sort of pots, but we can also move them and we don't impact the parking underneath. But maybe if there is more extended future, is to remove the parking and fill it with earth, and and we could have trees in the middle. Now, another idea is to multifunctional space. There you see the social dimension, which is taken into account, trying to bring population closer to nature and to the green spaces. So you see the example of uh, soccer field, for example, or pitch that could be provided. Also, fountain zones, as you see on the images on the right-hand side, with the top zones which could be provide coolness. Now, again, the Terreau Square, second site, again, the idea implemented there was that of water mirror that will remind us of Bordeaux, of course, the city of Bordeaux. But the idea is to have the freshness provided by water and evaporation, but to keep the functionality of the square, but then water can be removed, and we think about events like the Fête des Lumières or where the square needs to be to keep this functionality. Again, if we wish to push the development or amenities, well, by pushing the idea of implementation of infrastructure, green and blue infrastructures, we can well imagine to to have a water wall and to separate it with vegetation. Now, just to sum up as to the production of images and how they can be used, there are a lot of positive aspects because this generation of images makes it possible to visualize change, to visualize the the space occupied by new infrastructures, and therefore help in the decision-making process in the context of droughts and floods. This generation of image can help to raise the awareness of the population and decision maker in a future that might not be that far. And finally, it can help to build trust and understanding of what could happen, what can be built, and help the populations, but also the local players. Well, of course, we faced several limits, and we kept four, which are a clear illustration of the limitation of that tool, of this focus tool. Maybe they might not be faced by another software, but this is what we faced. First, generation of trees or any large vertical structures like trees that are tricky. Problem with the scales and the representation of human beings. It was easier to remove them than to include them. Unlike the wide vertical or thin elements, there could be problems. For example, everything that has to do with the light and shade, but such as water vapor. And finally, another element to bet is the quality of the initial photo, which is to be almost perfect if you wish to achieve a realistic result. Thank you. I am done. Thank you, Margot Sean. Most interesting, well illustrated, and of course, thank you to your group, which was involved with you which was in you for the involved in you for the position of work. Now, we'll give the floor to Pierre Audisio, who is a PhD student at the physics laboratory of the Lyon Higher School and the UMR, UNR AVS, and he will discuss the utilization of AI or some of it in his thesis. Good afternoon. I hope you can see my presentation. Thank you for your invitation and congratulations for the organization. Today, I will describe the work I do within the framework of my PhD thesis and the link with some AI methods. I'll start with, let me introduce myself, the purpose of my thesis, my PhD, and then I will describe the data I work with and the applications and the results. As students said, my name is Pierre Audisio. I work with Nelly Pustelnik, who is my PhD director, and Barbara Berletti, who works at the EVS UMR, Environment Cities Society. The project is called GLOURB, Global Urbanization. This is the problematic. I want to characterize the impact of urbanization on floodplains at the global level. It is quite a wide topic. You can see all the study sites selected and on which we're going to work as the project will progress. And on the right-hand side, you can see the 4 PhD students who are the cluster of PhD students for this. So each uh, student has a specialty. Jocelyn is specialized in ecology, Lyolia in social geography, Fanny geomorphology, and I'm more specialized in the technical and physical aspect. They have, we each have a study zone. My study zone is quite limited. You can see on the right-hand side. Always consider that we at the scale of floodplains, and it represents a surface area which is quite huge. I work, as you'll see, on Sentinel-2 images and the river corridor here. You see here, it's 2 to 4 images, Sentinel-2, which is 2 by 2, 250 kilometer by 250 kilometer. So this is a diagram organized during my first year to look at myself as I moved on. I didn't work in, well, I should start from left to the right as time was moving, but I started, in fact, here with extraction of some indicators, as you will see in the results. And then I will describe at the end the work I do, which is the increase of the Landsat data you see on the left-hand side. This I should have done that before. But anyway, to increase the spatial resolution. Now, the idea is to use 2 databases, one composed of satellite images from Sentinel-2 from the European Space Agency, and a second database composed of Landsat images. Landsat is a project that comprises 8 satellites, if I'm not mistaken. And the advantage of using the 2 databases is to, well, to achieve better quality. Sentinel-2 images have a high resolution, up to 10 meters, whereas the Landsat images have a high temporality, as you can see with the dates. You know, the Landsat mission started in the 70s. So the idea of combining these 2 databases is to densify the data, all the data we can use, and also to increase the space resolution of the Landsat data, which is 30 meters, and we want to bring it uh, sort of zoom in to 10 meters. Then we want to extract indicators that will help us characterize the impact of urbanization on floodplains. We call them descriptors. Descriptors will be specific, such as the braiding index of the river, the mean width of the active channel, and of course, the lateral variation. But since we want these are multispectral data, descriptors that will follow, they monitor the variation of values depending on the spectrum band, B11 from Sentinel-2, B3, Sentinel-2, which 20 meter and 60 meter, but they can also consider normalized indicator, which spectral, which would be the NDWI, which will tell us if there is water or not in the zone under study. We will localize the change within the geographical entity we call DGO for disaggregated geographical object. Those DGOs makes it enable us to separate the river in several portion or sections, and we have a final analyze and second step. Third step, we want to define a classification method, you see here, bottom right, from which we will be able to determine the origin of the change. So extract descriptors, localize change, and identify the origin of change. Using this central column, we know where AI will be applied. Now, how much can we do it? Now, concerning the data I used in the first part of my thesis now, we're dealing with Sentinel-2 data. I was able to work on the Lhasa River in Tibet, which is here. I don't know if you see this little portion in black here. I did my best so you can see it. And I selected this river because it has geomorphological characteristics which are varied and which make it ideal for study. You see section which will be anabranched, which would be a sinuous or braided. Yeah, you see here, see? And there could be elements that will be more rectilinear or meandering. So three geomorphological characteristics found in many rivers in the world in only one location. So that was an ideal test study site. So you see a DGO example, as I said, disaggregated geographical objects. So you see, starting from left to right, you see the entire river traversing the city of Lhasa. I worked mainly on DGO 19, which is on the right-hand side, green. You see, portions are very thin and which will be more difficult to detect where there is water, of course. And in the lower part, these are sections which are wider, but which always have this meandering dimension. As I said, two databases, one Sentinel-2, one Landsat. You see here some of the characteristics, which I could summarize easily. For Landsat images, spatial resolution stretch from 10 to 60 meters. When Landsat, beyond that, we go from 30 to 120 meters. And for spectral band used by each satellite, we got 13 for Sentinel-2, whereas in it's only 7 for Landsat for the spectral bands. Another information to monitor the rivers in time is we have the frequency visit on with Sentinel-2, we can have an image every 5 days. For Landsat, it's every 16 days, which is quite has an impact, especially if you want to do fine monitoring following sudden intense events, natural events. We need the images rapidly, and Landsat is better in that respect. Now you can see a set of NDWI images, normalized difference water index of the Lhasa River in 5 different DGOs. Zones, the lighter zone are the ones with most likely to have water in the pixels, whereas the darkest one are those where there will be other categories of uh, such as ground, buildings, vegetation, any other type of elements that we see. Here we see the spectral bands used for Sentinel-2 to calculate the NDWE, the WI, sorry. And now that we know this, let me describe some of the methods I used that enabled us to achieve the first results in these DGOs, these extraction of images from Sentinel-2, which are turned into NDWI. Three methods were compared. First one and second one are so-called the threshold methods. For the NDW of value from zero between value 0 to 1 belong to water and 0 to -1 are most likely to pertain to other classes. For the first second method, we selected what we call thresholds. The first, the second and third method, sorry, the two mentioned, the OTSO and the hard thresholding methods, we select a threshold either in an automatic manner, we do for the OTSO method, or where we look at the distribution of the value of pixels and we look where is the minimum value to basically find a point that would create a border the between the various distribution. You see here we got a high column on the left and major assemblies on the right hand side. So we see the most pertinent threshold should be here. We see. Whereas for the hard thresholding, it depends on the user. The user will have to choose the we selected 0 for the value because value distribution is between -1 and 1. And for the last method, it's a method so-called optimization method, which more complex and which closer to the so-called machine learning method. Then we do iteration, and we'll ask the algorithm to get as close as possible to place the pixels in two groups, which have to be as close as possible to the values we indicated initially. In my case, I did -05 and -05. -05 will be for all classes that do not belong to water, and -05 for classes that belong to water. Why not -1 and 1? Well, to have a certain margin of error so that the algorithm can navigate around such values, and we don't want to have extremes that would produce more uh, rigid results. The three methods were used to obtain segmentations on the NDWI image you see on the left-hand side and color on the right-hand side. And what is a segmentation? Well, basically, it's a method that tries to isolate the elements of interest indicated by user, here water, versus the rest. So in my the first weeks of my thesis, I used this DGO by chance, but quite randomly. But in fact, it's quite good. We got a lot of details, especially this little head here, devil's head, and you see the mouth, the eye, the ears. It may sound a bit funny, but what's important is the detail is that we can assess the efficacy of the method used. Here you see three results of the segmentation method, the two threshold method, hard threshold and OTSU thresholding, and the optimization method, which is close to the machine learning method upstream, at the top, sorry. So you can see the OTSU is quite poor in terms of results. You see the abundance of details will have disappeared in the OTSU method. We can see then I made the figure above. We have the geomorphological shape of the river. We see our little devil's head. You see section 2, which continues here in the normal continuity of the river. For the optimization method, we see the result is still satisfactory. We see details, but where I put the mouse, you can see that it's been cut off, unlike the hard threshold method. So then we can ask ourselves, that's strange, because hard threshold is indeed all the values below zero are being not water and above as being water. This is a method which is more complex, which will try to optimize many parameters. And there, what happens is that it doesn't segment well. And of course, then we go back to the previous images we see here. We could say, okay, what may have affected my segmentation on my optimization method? Well, and eventually what we see, if we compare with the color image on the right-hand side, is that there is the shadow of a cloud. Now, this is the worst enemy of people who do satellite imaging. And the shadow may have an impact on the results of the slide, our segmentation method. So it will totally create a bias on the information we try to collect from the river. Here we could say, okay, the river is 50-meter wide and it is closed there, and it came to 10-meter. I mean, it's almost closed, and then it becomes huge. So that could be misleading information that we have to bear in mind all the time. And now I will talk more about the deep learning methods. This method, this method called, it is a reconnected network. It's called Sophie Canero Esteves has created that. From the Clermont Vein has developed this deep learning method. We've integrated that in our optimization method. Uh, so we're dealing here with a topic which is interesting. That is this method. Sophie designed it to create a reconnection in images already segmented, or already binary images. We got the values of zero, black, white, black or white, 0, 1. She developed this to create reconnection in the blood vessels. You can see here and the eye, eye fundus. So you can see this is what doctors see with a zoom on 3 different zones that you can see, and you can see at the top left, um, and you can see on the right-hand side the application of the reconnector network to this image. We concentrate on the little green square where we can see reconnections were done in a clean way, and therefore we're able to recreate connection between blood vessels which had disappeared because of the acquisition method. Very much as if you take a snapshot and objects are missing because they've been hiding, they've been hid by mist or whatever. See, if you use this type of method, the machine can actually, using the pixels, they can consider what should be in the middle there, and they actually reconstitute it. And this is quite significant, especially in the medical field. And we thought, okay, why not use it to segment our rivers or integrate it in the segmentation method for the rivers? And there we took the Geo 19 with quite a fine section of the river at the top and wider at the bottom of the image, you see, but of course this ana branch characteristic of the river, which complexifies the study site. There you can see 4 methods for segmentation: high thresholding, as I said earlier on, hard thresholding, which gives, I said, also thresholding with results which are biased or impacted. We lost details a lot. Another the optimization method I showed, and the optimization plus the GRECO, the reconnector network. And here to simplify the visualization of reconnections done by the deep learning system, Jericho, we kept only the outline of the segmentation. Here we had the entire zone in white was the zone that had been segmented in a land zone, and black as being the water. And we kept only the boundaries between the various zones to see the behavior of the reconnector network. What we can say, looking at these four images, and if we ignore the Otsu method, which is poor, but it's good to get a low reference, well, in fact, we each time we get results which are good. And what will change from one method to the next between the first and the last two is the disappearance of some elements. We can see for the optimization method, proximal optimization method, we lose most of the isolated objects found here top left and which still see in the hard thresholding method. And this aspect is if this is more obvious in the proximal optimization method plus the Jericho method, which is supposed to establish reconnections. Now, we lose information significantly, and we can see that for the fine segment of the river at the top, again, there is reduction of data, which will remain until the end of the algorithm. However, in the bottom part, we can see that the Jericho algorithm did a good job versus the proximal optimization method without Jericho, but also versus hard thresholding. If we look only at the outline, sorry, but for artificial method, you can see that those are elements that are scattered. We don't see the links or the connection that could exist between the various elements of the river. Whereas for the images on the image on the right, by using the Jericho method, we have something which will be more homogeneous and more coherent. We can see that sections will be recreated here. You see, I indicate with the mouse and above, unlike these fragmented elements we had just in the result on the left-hand side where there were holes. So basically, I wanted to show you this example because we can see the transferability of the deep learning method. There could be a deep learning method developed for a certain application, but this application is quite similar to what we study, or if we can retrain the learning method, and well, nothing stops us from reusing it, unlike functions more common, which are ultra specific. Now, I'm done with this result for the segmentation of the river. So I want to show you now the work done currently, which will use um, the deep learning technique. It is the improvement of the resolution of the Landsat. Left is a Landsat image. You see the resolution is not as good as the Sentinel image because in Faithful Landsat, we got pixels which are 30 meter, where Sentinel, it's 10 meters. And even if images are already are, we see the difference. The idea is to merge the two images at the deep learning system to a deep learning. We feed it to a deep learning system. I said, I want you with this image on the left to obtain quality similar to the Sentinel-1, and we'll give it major chunks of data. I'm training a neuronal network with 400 pairs of images, which is very limited because when we look in the literature, a lot of models are trained on 1 million data. That is 400 is limited. So we need a method that will optimize data to have to so that we don't need to have too many. And the first results we obtained were the image we reconstructed on the right-hand side. It's not amazing, but it's we moving step by step. Now, to train this network, we had to create a, pairs of Sentinel and Landsat images. That's a full-fledged work. Neuronal network are great, but it costs a lot of money, and well, the more computing power, and don't do it on your laptop if you want to keep it alive. Otherwise, and also concerning the preparation of data on which the neuronal network will be trained. This is a diagram on the methodology I followed to create this couple of data. So What was more complicated was to find zones where Sentinel-2 and Landsat images were well aligned because the neural network can be transferred from one method to another, but at the time of the training, clearly you have to be very cautious and to feed it with coherent data. It's like, if you teach a child to learn to learn numbers in a wrong way, or if you teach him to do arithmetics in a bad way, he will follow this for the rest of his life. The neural network is the same. The Sentinel-2 and the Lancet image has to be superimposed perfectly so that he will understand what he's dealing with. Corresponds to the one on the left is the one on the right, and he should be able to do a transfer of information. He should learn from it. So that's the professional database, and I'm still working on that. It's a work in progress. Thank you for your attention. Thank you. Very exhaustive presentation. Very, very useful for the utilization of satellite images. Now, let's move on to the third part, the discussion. And you will be there with students from IWS in order to share your perception, understandings, questions as well on AI and perspectives we see. And I will now give the floor to Romain de Pierala, and Romain will facilitate the discussion. Thank you, Louis. Now, can you hear me? Yes. To kick off the discussion, we do have questions, and we'd like your opinions on about them concerning, do you think that AI could be a tool to help in the studies, or a full-fledged solution to answer questions in water science? This is a global question, yeah, and for the students as well, for whoever wants to take the floor, give your opinion on what you think about it. Well, well, I use AI as a tool mainly because a tool that will enable me to find a solution, but which will come up with existing elements. So it's not something that will be a solution per se. Uh, Unless I don't understand what you mean by total solution. The idea of the question is to know what is the approach when you talk about artificial intelligence. Is it full automatization of a process and loss of control, basically, of what goes on until you put a query, you get a result, and the result enables decision-making process, or is it more in the case of an application, there will be repetitive task, step by step, and that you will give to the AI, and we can draw conclusion with human supervision and to have a conclusion decision-making process. I think it's a mix of well, it's between the two, but to do repetitive task, it would be stupid to use AI. After that, it's very practical. We all use the ChatGPT, but to develop a method just to do one thing, all you need to do is to create a loop, a conventional loop on the programming languages to do that. But the fact that you use a deep learning, very much like for the super resolution method that I'm trying to implement and to use the database I've created, well, it implies that there should be a work from the create designers too heavy to do repetitive tasks. So the flexibility of learning methods, in fact, will be to it. This is what will be. This is what we will exploit. Don't Not sure I've answered your question. Yeah, yeah, yeah. Tout à fait relevant. Yeah. Well, on when I use AI, it was discovery, of more than just generating images or, to have the system correcting your text. What is AI and what can we do with it? I think it's quite relevant as an answer to say it could be between the two. You don't limit yourself to repetitive tasks, but you can ask the machine to do a work which for us would be complicated to do, and to have to trust the result for deep learning, for machine learning, and possibly of a full-fledged science with the processing of various types of data, water temperature, pollution, as we've seen initially with the decode article. So to understand the process, which are difficult to understand at the human scale, so it gives us another vision of of the processes of and not just images and data. If there are no other comments, we can move on to the second question for this discussion. I'd like to know what about the daily use of AIs, and especially in the professional field. What's your views as a future professionals? Um, just one question in the chat. Taking into account the scientific progress provided by AI and the resources to its operations, especially energy, how do you, as you mentioned it by saying that we should not use our laptop, could we consider this as an ecologic green progress? I don't think so. Well, it's mainly, I said that to save your laptop, but anyway, whether you run an deep learning algorithm on your laptop or on a cluster, as I do, your clusters would be clouds, of course, as they exist with Drive Google. In all cases, this will have a major impact on your carbon footprint. But, people are becoming aware of that with codes which are being developed to do a real-time monitoring of the carbon footprint versus electrical consumption of your program. Yeah, I'd like to react to that because in the lab where I work, we discussed that in this daily usage of AIs. It seems easy. We simply, for example, AI in your smartphone or the chat GPT, we don't even realize that of the power consumption, which is huge. And it says that difference between using this AI on the internet, using the AI in a local manner on a laptop. But so um, I don't remember exactly what the elements are, but I think there is a difference consumption between simply asking a question AI and asking several questions, because well the multiple questions will increase the power consumption because links are being established between various elements. So you have to be aware of the fact that AI is not green when you use it on a daily basis, but clearly you have to change there's a higher power consumption, so it's not green. So in terms of utilization, are you aware of it, but you use it anyway when you need it, or are you trying to reduce the nature of your questions and the fact that there are embedded questions or intricate questions like that. Well, we're aware of that when when I will use an AI. I always think about that, but for the time being, I haven't changed the way I utilize it. Uh, for example, local utilization to install this on your laptop. It's heavy, but it doesn't have the same efficiency. But when I use it, the I said to myself, "Ouch!" You know. Thank you. So, Pierre, something to add? Yeah, I want to mention the fact that when it comes to the laptops, uh, is to see the physical impact on the machines of when you use this type of model. As you say, if you use it on the internet, we receive the answer, but the machine that carries out the computation is in the US or elsewhere. But if you do it on your laptop and you can see that once you do a query on your on algorithm you created yourself, you can do nothing else because your laptop is 100% used to do this task. You realize the computing power necessary. You realize the computing resources necessary to achieve the answer. It is true that the in all the social and ecological aspect, this is something that we use more and more. So it is quite relevant, for the link, for those who didn't see, Pierre shared a link to have a carbon footprint calculation. Now, to follow on the initial question on the daily use AI, uh, well, the AI, I think, provides a vision we don't have. I have a feeling that the climate change, when we talk about it, I've been talking about climate change, but everything that has to do with disasters, climatic events, in everybody's mind, where you're in flooding zone, there could be forest fires, but it's the sort of sort of immaterial. But this generative AI like this uh, is a tool that for awareness raising, for communication, could be a strong tool, and to remove the uh, the fantasy and have images, that you put, the things that people are used to see, with monuments or the squares or locations, where they spend time, and then the place this kind of situation, this their reality in what we're trying to convey, in what could happen, and it gives another dimension to the awareness raising, and I think that is clearly interesting. Yeah, to react to what you're saying, I fully agree with that, and this is the observation we made. Did for the generative AI. It's not that I don't see the interest of AI to show what you don't see. So to raise the awareness of people, but I think there is also the limits of the tool, which has to be taken into account because it's quite significant. I don't think I will be changing the world by showing photos that have been generated by artificial images. And what should be taken into account is the difficulty of utilization. Of course, we did not have any specific training to use this tool. It was a lot of test and personal learning, but there are a lot of constraints, requirements, which has to do with the realism, the realistic dimension of the image, and this lack of realism to me is damaging the awareness raising objective. But once again, what I'm saying should be taken carefully because with a pinch of salt, because it is um, what we felt with the software we used and in the context where we didn't have any sort of a training on this. Well, I'll take advantage to continue on the awareness raising. How do you envisage on your side, with the experience you've had on AI, to integrate AI in the next 10 years, for example? Could you do a bit of forecasting here or, perspectives, what we mentioned, responsible use, taking into account the energy cost and so on and so forth, data management as well. I have to say that I think I will use AI. We're talking about generative AI, yeah, for awareness raising or any type of AI or types of all types. You use generative. So when it comes to awareness raising, I believe that if one day I need to work with managers, syndicates, water syndicates said I must propose a project. I think why not use it to clarify my talk with by using images, for in front of people who might be a bit uh, skeptical or don't have the vision I want to give them. No, in line with that, we are dealing with dynamics of efficiency of AI calculation. And honestly, I do believe that in the near future, we will drop this carbon footprint when we see models, even on the language model or Dixie compared to ChatGPT, for example, well, which is more efficient with consume less energy. It's quite promising for the carbon footprint. Thank you for your participation to this discussion. Move on to the Q&A. Now, to close the discussion, it was interesting to have your opinion on what is coming with AI, and we'll see. Friday we'll be able to use three other examples of application that will help us imagine what will be the utilization of AI through the example of and the three next example that we'll have on Friday. Now, for the questions, let's start with questions on GI, generative AI. Chat question was, how long did it take you to achieve a satisfactory image? Long time. And still, you have to make sure that the images are satisfactory at the end. And lots of frustration within the time given. So my colleagues will agree with that, I'm sure. At the level of time, with concern the time, well, I believe that 3 weeks, 3 solid weeks. with lots of touch-ups. Well, 3 weeks, but not all day long. We do a couple of hours, we go back to it. We were learning ourselves. We were learning how to use the tool because we discovered it with the project. There is this discovery test and also the difficulty to the more we wrote prompts, less was the higher the number of prompts, the lowest the efficiency of the AI throughout the iterations and the reiterations on the images, because the purpose was to take one image, to modify it, and to take this modified image and to remodify it, and so on and so forth. And in fact, the AI is getting has more and more difficulty to correct its own correction, and this is a limitation of the systems. It can take a lot of time to generate an image, and especially if we don't use tools online or on a computer, it's between 15, 20 minutes and well, 5 and 30 minutes. So it takes a lot of time, and a satisfactory image can be obtained in one day, but it's a lot of work. Okay, well, thank you for your answers. I think it gives us an idea of how to use this tool. And now to react to the utilization of the tool, do you think that you will use it again in the future for your utilizations? Yes, personally, it's a tool I could reuse. Yes, indeed. It all depends on the context, but for the illustration, I don't think I would use it in a scientific context or for results I want to achieve. But honestly, for an illustration, why not? Not really a scientific usage to put in an article or something like that. That would be, yeah, yeah, yeah. Because as Margot said early on, it's lack of precision, accuracy. Uh, the result is a bit misleading. But the result is a bit, it looks artificial. It looks false. But to have an illustration somewhere on a PowerPoint, something, yes, possibly, why not? Agree with Arno. For me, it is something to be used in addition to, if we consider that we will help in the decision-making process. It's not the image uh, can be used, and I think with more practice, more training, we can achieve more satisfactory results, which can be used within this context. But even well, in my opinion, even with satisfactory image, there will automatically be a major discourse for awareness raising behind it, advocacy. That's great transition to the next question. Can it be a good tool for awareness raising, for advocacy? And it's a trompe-l'œil. It's misleading. So what do you think? Uh, can we use this to raise the awareness of people, to do sensibilization, or other things to improve still with this tool? Well, there will always be something to be improved because it's as long as it's not realistic, we can ask for more. But at the same time, there is one aspect which is quite satisfying. It's not necessarily highly realistic, not as realistic as an image, because it raises the issue of the utilization of images, the utilization of a false reality, and to present an image and to claim it is true, whereas it is fake. Basically, we're creating fake images. So we I understand Margot's opinion. It's not realistic enough, and it may damage the value of the message. Um, there are also those this aspect, the negative aspect on the. Sorry, I missed that part. Just add something about the generative models. These these are images should be understood by man, but I have a colleague in the laboratory of physics who works on what called texture, that is repetition of data frequency in your image by we a lot of pixels which have a given value and others have another value. And in fact, these images should not have well you will not see object human eye. You will see mathematical notion which will be applied to the image, but there models can generate lots of data of such kind in a good way. And there we can also do establish a parallel in this. That is for what could be understood by man. There could be complication with generative AI, which will create objects which might not be uh, natural, or at least which will not have a real meaning. But when it comes to the application of mathematical model, well, the AI will be able to create data and to uh, uh, establish specimen, which could be very long to create with classical methods. So for mathematical formula, it does work. Thank you for this vision. We don't necessarily have at IWS, or students don't necessarily have a mathematic background, so it's a vision different from what we used. And we do have a couple of questions vis-a-vis this work. First, how do you combine the two database, the two images, and is it a type of approach that exists, or is it something that is being developed in addition together with your PhD? Your thesis. Well, I don't start from nothing. Lots of methods do exist, but each method should have its specificity. And this is interesting to work on that. We all want to add something, but some people will, well, add a Landsat a Sentinel image. Well, they will use the Sentinel image, will degrade it, and will try to improve the quantity, the quality of the Sentinel images. So there are methods that make it possible to improve the Sentinel images up to 5 meter resolution. But there are many, many methods, different methods in the literature that will be based on several aspects to create this algorithm for super resolution will increase the resolution. In my case, this is something that has already been done, but not in satellite images. And satellite images, so, provide a complexity which is quite annoying, to be honest. That is, there should be a preservation of geographical information throughout the transformation. I will not, it's not new for you. I'm not teaching you anything new. When you open a satellite images on QGIS, you can see that some projections are associated, but when you work on images with a high super resolution segmentation and others, you can quickly lose the uh, the metadata aspect, metadata associated with that. So this is the specificity which is new in the method I'm trying to develop. But the super resolution method per se is not something new. It's already present in the literature. And these are things that people have been trying to do for years. Thank you very much. A question as to now, I don't understand the notion fully, but this notion of overlearning. Well, to develop a model of an image with the quality resolution we have today, and the resolution of image not as good, but with the comparison of the two time period, we can test the AI to reproduce images, but the images where we don't have the current version, we cannot actually compare the result of the AI. So, do you have problems with that on the overlearning? They're very good with the images we have today, but if we move on to older images, well, they face difficulties to get an improvement of the resolution. What we do uh, uh, during the learning of the model, the neural network, the model will receive a train set and an eval set. And as you can imagine, eval is for the evaluation, and the satellite images, there is a variety on the ground, which is so significant, huge that if your model is properly trained and you assess it properly on your eval data set, if it gives good results, it means that eventually this model, if you apply it to a Landsat image for which you have no reference, you're certain that it will work because you did an evaluation. It's very much like when I talk about a student, and if he learns and he has a good mark in the exam, we 2 days later he should he should still be able to answer. And this is the point, a key point, that you insisted on, because we train for Sentinel is from 2015, so we use message from 2010, but we have between so this is we only have Landsat now, Landsat images, so we do a replication of the model, and by saying that it will work properly. Thank you. Before conclusion, one last question. Okay. Now, do you think that those are methods that could be applied to or uh, data production organizations that provide regular data based on the open? Are Can this be used by everybody, or will it remain a sort of a cluster of people capable of managing this and to produce these images? Well, it's a good question, actually, in as much as the advantage of this method is that, as I said early on, is to densify the quantity of data available as of 2015, because we will have more data with a 10-meter resolution. We'll transform the Landsat, and we would increase the resolution of Landsat between 2015. But in fact, eventually, in the last years, there's been so many data acquisition projects from space available that we do now have much finer resolutions. We can think about the Pleiad satellite, which can give in hyperspectral imaging 30 centimeter space resolution. So the idea is for the users like you and I to make the effort and to find the models and to apply them to increase the quality of data available. But whether it is done massively by the state or the agencies or used, I don't know. I can't tell you. I don't know. It will depend on the production and the if people can hear about it, learn about it, and be able to use it because it is prestigious enough. Thank you for your answer. Thank you all. Thank you all for your contributions.